Hey everyone, Eyal here. Hope you can hear this. There's really a funny preset of AI generated music that is called the Halloween preset. I don't know if it sounds like Halloween, but you know, it's one of these things that I can play without getting my stream taken down. So it's kind of fun. So for those just joining, my name is Eyal. Some of you know me from my music, from my bands like Project RNL, my solo projects. Some of you know me from my music software stuff for different companies, for my company Modalix, for Waves, Xfer. Currently, I'm also working with a company called Music Hack, which is awesome. So today is going to be one of the only streams that I've done that is pretty much not audio related at all. It's really going to be a learning project for me to learn how to work a little bit with OpenGL. I've tried that a little bit before, without a lot of success, just because I never had time to sink my teeth into it. But now I decided that I want to, pursue a little bit my hobby project of making a few simple games. I think I would probably start with something like a puzzle game and kind of build myself up to the dream game that I want to do, which is probably going to be like a simulation, something like my favorite game of all time, which is SimCity 1. So I might make something like this. And this would be, hopefully a fun shared learning project of me going through things that I don't know, but hopefully some of the C++ knowledge and programming knowledge that I have sort of gathered knowledge. I don't know, something about knowledge that I already have would be effective in doing this. I'm not going to use any kind of engine. I might use a couple of libraries, but it's all going to be plain C++ for now, at least. This music is really dramatic. Let's see if I can switch to something else. Yeah, so how's everyone doing? For those who don't know, I'm streaming this on a bunch of different platforms. This goes on Instagram, Twitch, YouTube, X, LinkedIn. So I can see comments coming on screen from different places. I would try, if you say something, I'm going to try to put it on screen and see if we can all somehow join the conversation. So here's what specifically, let me turn this a little bit down. All right. So let me start talking about what I've done so far. I just did very basic things. The interesting thing about this project, just like I said before, is I don't know anything about it. I know a little bit about how C++ works. I know a little bit about how frameworks work. But I definitely don't know that much about OpenGL. I did do a little project, which I'll show you in a second. I probably need to make that other project open source. But one thing I did a few months ago is that I wrapped a bunch of let's see if I can load this. So I wrapped a bunch of OpenGL calls to make first of all to learn, but also to see if I can take shader toy examples. So Let's run this for a second. So I'm just opening the modalics code for a second because I did it in the modalics code project. But what I did was I made this thing where it's like a juice project, and it can take, ooh, what's that? Oh, I may have updated Xcode or something. I hate when that happens. When Xcode gets updated and then I need to recompile things. Anyway, the idea is I made this thing, and you're about to see this, where I could take almost any code from Shader Toy, and Shader Toy has a very specific format as well. And I made it kind of work in juice context with different sliders controlling it. So that was a really useful thing for me. This project would hopefully be a bit more, gritty, as I want to learn the different calls. I want to see if I can create, more interesting drawing calls and stuff like that. So let's wait for this thing to finish building. All right. And so what this does, this is just code that I got from Shader Toy. We're going to try in a second and work with different shaders. And the idea is that I can take a slider here, you see, and I can move it back and forth and get this beautiful animation. Same with here, it's all independent, right? And let's get another code. Let's go to shadertoy.com, one of the greatest websites known to man, if you've never tried it. So Shader Toy. And let's pick up something else. Let's take this one, for example. I'm just going to copy paste the code into a file that I have on my desktop. Let's see where it is. Here it is. So this is the file, the fragment shader that was copied, before. I'm just going to replace that code, save it, and unless this does something very special, like some Shader Toy shaders are doing more complicated things. Here it is. So this just loaded, and this is the new shader that I got. It's connected to my code, and I can move it very smoothly. There you go. Look at this beautiful shader. So nice. And it would actually be good to look at this project, because this project probably has a lot of similar things in what I'm going to do, just because there's a lot of wrappers around OpenGL calls that I made to make them a little bit more C++ friendly. I don't know if I did them correctly, but they were kind of the basics that I got that could work. Yeah, this is, by the way, a beautiful website that you should check out, Shader Toy. I'm not saying that anything that I can do is on that level, but I think it's a great learning resource. Yeah, so how's everyone doing, by the way? I see a few people joining on a number of different networks, so let me know if you have any questions about what I'm doing. Because this is the stage where this is going to get pretty technical. But basically, one of the things that I did here, which are interesting, where's that? It's called Shader Tester. There's a module somewhere called OpenGL modules. OpenGL. Yeah. So the one file they'll probably take a little bit from is this file. there's a bunch of helper functions there that just helpful to I have no idea what I did there. I'm going to need to reread most of this stuff, but it's just like stuff that I did to wrap around stuff like compile shader, link program, all kinds of like syntax things that I think you pretty much always need. And then we can slowly kind of go through, what's the best way to do these kind of things. So as I said, this project is going to be me wrapping OpenGL stuff. So in my other project, this is the project I'll probably going to be working on. In this project, there's not going to be any juice or something like that for now. So what there is, there's two things here. One is I made basic wrappers around OpenGL. So maybe I should explain a little bit about the structure, because I'm going to try to work in this structure or elaborate or expand on the structure. So the idea is that there's a few folders here. I wish I could zoom. For some reason, I can't zoom because of this way that I'm streaming. Hopefully, this is readable enough. So Bar Moshe is writing on the chat saying, "Try use this shader," but I'm not sure which shader he's talking about. But yeah, but I can basically, in my wrapper, I can use any shader from Shader Toy except for ones that use stuff like the keyboard or the mouse. So it kind of works, but it's not very, it's not what I want to do. Even though it did teach me a little bit about the structure that I need to relearn now because I forgot all about it. But the idea is that I don't want to be, a lot of these shaders that people put on Shader Toy, they're amazing, beautiful, artistic things because they kind of try to encapsulate the logic of the movement. Like they do all the manipulation on the image inside of the shader, which is not ideal. Because probably what I need manipulations like animations, etc., to be done in the C++ code where the game or app is going to be written in. So I'm going to need to write this in a way where, for example, if the shader is dynamically written, usually the shader would have some, a few basic commands, and then the C++ app would pass into the shader things like, the actual state of the program and where things on the screen should be. And, if we have, let's say I'm going to do, eventually I'm going to build into a simulation game like SimCity or SimTower or something, then I'm going to have, probably I'm going to have a bunch of either images or textures or things that are supposed to be dynamically moving. And those stuff would not happen in the shader just like they do in Shader Toy. Those things would happen pretty, like it would happen in my game logic. But the game would kind of decide what's going on, and then it would provide positions and coordinates and colors and textures and all that into the shader dynamically. So all the time messages would come in from the game or the game engine or whatever it's going to be called, and then it would be copied. Okay, so let's talk about what I did so far. One of the things I did so far is that I wanted to abstract away all the libraries that I'm using for system stuff. So for example, now I'm using SDL to get keyboard input and to create the window, stuff like that. So what I did was I created a so here I made like a target called SDL. This one currently has a pre-built version of SDL for the implementation, so that I'm linking against. And this is like a little CMake file that I wrote with a list of Mac libraries that it needs. I'll probably have a little bit of a Windows equivalent at some point here. And here, this is where it gets more interesting. Here I started to write wrappers so that the game itself does never have to include SDL or OpenGL, right? So ideally, the game would have these abstracted calls where it only needs to include them. And this is good because I eventually don't want to use, I might not use OpenGL at the end. It's very possible that once I make more learning, advancements with OpenGL, I'll probably switch to more modern things like Metal, Vulkan, and other more advanced formats. But OpenGL is good for me because OpenGL is, from what I've seen, by far the most documented one, and that's why, which you will see pretty soon, we are gonna consult a lot of ChatGPT and stuff like that. For example, when I tried to work with ChatGPT with the new SDL3 GPU API, which is more modern and uses Vulkan and all that, it caused a problem because ChatGPT did not know about it. It's very new. But OpenGL, it seemed to know pretty well. It seemed to know, it seemed to have a good grasp of it. When I Googled, all kinds of like Reddit questions or Stack Overflow questions, I found way more examples in OpenGL than anything else. So that's why I really want to, do my best to work in OpenGL. Anyway, how's the audio, by the way? Is the audio okay? Is the video okay? Am I too? I don't know why in my previous screen it looks like I'm pretty choppy. I don't know if I'm really choppy or is it just like my previous screen working kind of slow. Let's double check here. Maybe I'll if I reduce the change this, maybe I'll change that back. I don't know, does it look okay? Do I look super choppy? You tell me. I have no idea what's going on here. Please let me know in the chat. All right. Hopefully this is okay and not too choppy. Okay, so the idea is that when I made this thing, like for example, start app, this is actually doing a lot of private implementation things. For example, my test game here, I have a test game where I just tested keyboard input. So it's called games prototypes basic game. Let's try with that. So this is only the code for basic game. It doesn't include any of the real SDL stuff. Like I can call SDL whatever. Like I only have my own SDL namespace, but I can't access any of the SDL internals. But I did do stuff like let's remove this. So I did create callbacks. For example, I wanted to create a callback whenever a keyboard event happening. So I created a stud function. This is all in my own code. And I did something like, let's do something like a stud cout. So for example, let's do something like for audio key. Do this. So keys equals this. If keys are not empty, go through the keys and then stud cout key dot key. I wonder why my frame rate is so low. Something is definitely taking over my frame rate. Maybe it's just the stream setup itself, or maybe what else could it be? Let's exit this stuff. I wonder why. I wonder if I hope I don't need a restart or something. Definitely getting some pretty low FPS. All right, so let's see what this does. This is just my basic game. It's going to run. Let's open a window with nothing on it, pretty much. Oh, you know what? I know what I might need to do. Let's see if we can change the... All right, good, okay. Let's also add std_nl. Let's do something like stood pressed. So what I was going to do is I wanted to see if my update loop runs correctly and keeps printing what's being pressed on the keyboard. There you go. So now it's not. Oh, I forgot to do. I only want to get it if it's not empty. Hey Miguel, thank you for joining me. Okay, so this is the amazing window that we just built. I'm gonna press keys. Good, good. Okay, so let's see what happens. You see, when I got pressed D, but before that, when I had more than one key pressed, I would get pressed D and A at the same time. So this is really what I wanted to test. I wanted to see if I can observe in the update loop what's being pressed. That was the check that I wanted to do. So yeah, so this is my general framework that currently happens. It abstracts inside of it. When I call start app, this abstracts all the creations. Like there's a bunch of callbacks you have to register with SDL to whenever an event happens, whenever init happens, stuff like that. And then I abstracted that. So for example, when I get an event, I don't handle all events. For example, I don't handle mouse events yet, but I do handle key events. So I do that whenever an event comes in. If it's a key event, I'm registering it into this little wrapper that stores the key so that my update loop can later observe that. Oh, so great comments here. So first of all, Miguel says, switch from audio dev to game dev. Not yet. I'm still doing mostly audio dev. Speaking of which, there is now the Black Friday, deals on modalix.com. So you should definitely go there, see our Black Friday deals. We just started them, so check that out. Yes, I have not stopped doing audio dev. I'm still doing Modalix, and now I'm working also for another company called Music Hack that does an amazing mastering plugin called Master Plan, as well as new plugins that are about to come out. So yeah, so I'm still doing audio dev, but I think that I just wanted to spend some time on the weekend or evenings to learn a little bit about something else and maybe get learn new things. Maybe those things would also find their way into plugins and maybe not, but I find that it's a world that I want to be a part of. I want to be making at least simple games, at least know more about the practicality of it. Remy says, hey y'all, just giving you big ups for Waves Bass Fingers. Really well done. Yeah, awesome. So glad you like Bass Fingers. For those who don't know, Bass Fingers was a plugin that Or Lubianiker, my partner in Project RNL, my partner in Modalix, he and I made this plugin when we worked for Waves. That was one of the projects I'm most proud of, that one and Bass Slapper, which is another version of it. I really love what we did with this plugin, and yeah, you definitely should check it out. It's not expensive. It's got a bunch of algorithms for articulation management and fretboard management, and you can kind of customize how the fretboard works, which strings are used, and how the finger logic works. I think it's really cool. I think it sounds great because Or Lubianiker recorded all the samples with his amazing Mayonnaise bass. So it's pretty beautiful. So you should check it out. So the question is, any framework or just SDL? I'm not going to use a high-level framework, but I would probably use a few things. Like it's possible that right now I'm using SDL for just low-level things. I might bring in, I most definitely would bring in something like GLM, which does like math over matrices for drawing. I might bring in a physics library. We'll see. Maybe I'll bring in Box2D or like one of the simpler libraries out there. Yeah. I probably would bring some libraries in. I haven't decided which ones just yet. Like it's also I want to make sure that I know a few basics, because I have holes in or gaps in my knowledge. Like I'm really good in the C++ side, but I think that I need to make sure that I know the drawing part at least well enough to do basic things. Yeah, it's a great example. Okay, so the question is, would you use some vector GFS library like Skia on plugins? And how would you include it in, let's say, Juice? You know, that is a great question. I don't know about Skia specifically. I've never tried it. But Skia is a very interesting library, and I know that the Juice team itself at some point considered adding Skia. Let me switch over to my other thing here. So I know the Juice team itself considered adding Skia as an option. I know that Skia is basically the rendering library that powers Chrome, I think, and a few other things. It's very good. I can say that the main issues that I've seen from Skia, and I haven't used it, so I can't say for sure, but from what I've seen, Skia, just the build system of it is pretty complicated. So it's going to be pretty hard to just incorporate. And also, I'm not 100% sure that Skia works well for something like a plugin, because in a plugin, the DAW owns the window. So not all libraries play really well with a window the host provides. So a lot of these libraries, like I think SDL, last time I tried using a plugin, which is a few years ago, SDL was giving me problems with the plugin, because SDL kind of expects everything to be global, and a plugin could have multiple instances with multiple windows. So it's not very simple to incorporate something like Skia. There are libraries that you can use inside of Juice that I know people have tried. Like I know you can use something like BGFX, but those are really low level libraries, so they're really good. I think that Matt Titel from Vital is experimenting. I don't know if he released it yet, but he's experimenting definitely with using more high-end libraries like BGFX. I think it's awesome. So yeah, so it's there are options. I don't know if, like, you need to test it, because of this requirement of the DAW, that the DAW exists. Like, it's not obvious to just bring in a random UI library and put it in Juice. OpenGL you can definitely do, but if you use OpenGL in Juice, you basically cannot use any of the Juice standard stuff. Like, you have to draw everything yourself, and you can kind of blend maybe, like a part of the window with OpenGL and part of the window with Juice, but it doesn't play well. So you need to basically change your whole paradigm of drawing, which is complicated. Yeah, the word is Vulkan for the win. Yeah, Vulkan. You can definitely make a plugin with Vulkan, by the way, but it's just that the build system would be a little complicated, and you need to draw everything yourself, which is probably what I'm going to do in this game here. Like, at some point, I'm going to draw everything from within OpenGL, or later on Vulkan, Metal, one of those, just because I think that's how you can get the best performance. So the question is, what about trying to drop Juice and go with a plain VST3 SDK? Sure, you can do that. It's just that if you do that, there's not really a really good solution for graphics. That's really one of the big advantages of Juice, is that it provides a really, really good graphics API that's cross-platform. If you would use VST3 SDK, the only option that VST3 itself provides is something like VST GUI, and VST GUI is just not as good as Juice. It's just a very old framework. It's not user-friendly. It has less features. It has more bugs than Juice. Performs not on the same level. So you're basically getting an inferior solution. And you can use something like a web browser API, and it would work, but you would need to write some bindings and window creation stuff. Like there's a bunch of low-level details that you would have to deal with, but it's possible, and people do that. And if you look at a library like iPlug2, they have bindings for a web browser. It's very nice. So I would, you can look at that option. There's a few options out there, but it's just difficult because of the requirement, the DAW requirements to own the window. You can't just put a random graphics library like you can with a game. You can't just say, okay, well, I'm just going to use a game engine. It's probably not going to work. You can't just, if you bring in Qt or some library like this, you might run into problems. So you have to consider if this is going to work in a plugin. All right, so you're doing game. Yeah, so I'm now I'm in a stage of just learning a few specifics, but it's very likely that I would be switching to doing an actual game at some point. Like, it's very likely the first game would be something very rudimentary, like a puzzle game, just to learn how things work. And then maybe I'll do the more serious game that I'm hoping to get to. But this is me learning and having fun, and just see if I can make sense of this. Yeah, and thank you, Remy. I really appreciate the questions, and feel free to ask or comment, etc. All right, so yeah, so as I explained, what I've done so far in my code, let me switch the scene here. There you go. Okay, so All right, so this is a great question, and this is the exact kind of question that I'm actually struggling with now. So I'm happy that you're asking this. The question is, since OpenGL is deprecated, would you still recommend learning the basics of OpenGL? So this is a loaded question, and I've been dealing with that question myself. Let me explain the history of this question. First of all, OpenGL is not deprecated. Apple have deprecated OpenGL specifically on their platform, but even though they did that, it still works. So first of all, I would be really surprised if it would be removed anytime in the next few years, because the day where OpenGL gets removed is the day where half the things on your Mac stop working. Like, it's going to seriously handicap your computer when Apple decides to do that. And I think, I found the day pretty far. So I can't say, it's not like I have some information. I have no idea when Apple are gonna chop off OpenGL, but I think that day is gonna be rough. I think so many programs still use OpenGL, and it would be just very difficult to get away from. But also, I would say, and this is just me saying as a non-expert at all, as you will see soon, I am not an expert in OpenGL, to say the least. I am very much a beginner in OpenGL. But, when I looked at the alternatives, when I looked at what does it mean to learn, Vulkan or Metal, I just saw that there's so few examples out there that are good. Even if you try to work with something like ChatGPT, which we would be working with, it's just there's not enough materials. It's just so difficult because if you're just starting out, there's thousands of tutorials on OpenGL, but barely nothing on the other ones. And I'm actually, my goal is to actually use, there's something pretty amazing that just came out that I would probably use once I'm a bit more familiar. So that's, by the way, a reason why I'm abstracting all my OpenGL calls. There's not going to be direct GL calls from the game. It's all going to be abstracted somehow. And I do that because my plan is to eventually use something new that SDL3 has, which they call the SDL GPU. I did not use it yet. I just looked at a few examples, but the idea is if I'm going to go, there is a file called, let's see this. So this is actually like ideally this would be where we get to after a little while. There's just, I'll explain why in a second. So there is this thing called SDL3 SDL GPU. So that's new. This is really new thing that just came out a couple of months ago. So it was not here in SDL2. And it's got all these things that they're basically very much, like kind of like Vulkan. Like you see this thing called the graphics pipeline and create GPU sampler. There's a bunch of stuff here that I've not used. Push GPU fragment uniform data. So these are basically abstractions around only modern APIs. So there's no OpenGL there. It's just Vulkan, Metal, and Direct 3D, I think. So it's just the modern APIs, none of the legacy stuff. It looks great, but the problem is it just came out. There's no examples. Like if you go to the SDL repo, there's no. I've only found like a unit test they did on it. There's no examples. There's barely documentation, so it's all very raw. But it is possible that once we clean up a little bit of the OpenGL stuff, I would switch to this just because it just looks so clean to use from an API point of view, and I think that would be the way to go. Would be an interesting challenge to develop a game in Juice. So, I mean, yes, but also I've done like dummy games in Juice in the past. Like this is how you learn. Like I did that. So it's just like it doesn't look like such an interesting thing to me. I just I have great control over Juice. I feel like I can do anything I want within the boundaries of that framework. So I feel like it wouldn't be so much of a learning aspect. And I really want to learn more about SDL, about these other ones, just to get. I feel like it would help me to feel like more like I'm in control, even though it's very possible that I will bring in Juice for some niceties. Like Juice has a bunch of like rectangles and lines and path and all kinds of like logical libraries that I might use just as intermediate ways to get from what I want. But yeah, but I think I want to do that first. Maybe if I have a deadline, I need to release something, then I'm going to use Juice. So you go barehanded to learn instead of using UE as in Unreal Engine. I mean, Unreal Engine would be for a different purpose, because if I use Unreal Engine, then I'm not going to write any graphics code. If I'm using Unreal Engine, I'm not going to write any like low-level C++ stuff. Or I mean, you can write some C++ inside of like the code that decides what to do during a collision, like logical code. But it's like I don't want something so heavy. Like Unreal Engine is super slow and heavy. It's all about like the graphical interface, which I don't care about. Not to mention, if I release something with Unreal, it's complicated. I don't know. I feel like Unreal would just be way too heavyweight for what I want to do, and I don't want to use a graphical editor. I think like graphical editor is just like not the right interface for this. I like something like this. C++ file compiles within a second. I tried to load Unreal last week, Unreal Engine, and just like the initial projects took like an hour until it loaded. I'm like, come on, this thing, the SDL stuff, compiled within less than a second. So I feel like I really want to do something that would help me, iterate and learn low-level stuff. So this is not a recommendation. There's a comment about like the Blender game engine. Sure, there's a bunch of game engines. I'm not going to tell somebody not to use a game engine, but this is not the purpose of this. The purpose of this is that I want to I want to learn how to do these things. Even though, again, if there was a deadline, I had to release a game or something, I probably wouldn't recommend somebody just study OpenGL. But I want to know more about how that works. Have I coded the teapot already? No, and we probably would code the teapot very soon. So that's coming up. Okay. I'm not sure why is my frame rate really slow, or is this just slow on my end? I don't know why everything looks super choppy for whatever reason. I just finished graphics course and end up developing Breakout. What do you mean by developing Breakout? What does that mean? Is that the name of a game? Breakout game? What is a breakout? Sorry for misunderstanding the lingo here. Oh, is that like the old arcade game? Breakout? Yeah, it's awesome if you do that. That's probably something, probably would be a great project for me. Okay, good. I'm happy to know that the frame rate looks good. So yeah, so definitely I think making a game like this would be great. I'm going to probably start with even simpler games. Like my probably the first game I'll do. Well, we'll see. Let's see what do we get. So let's go to let's see what do we want to do today. And again, and now this is getting to a land of me trying to read things. So what I did, I opened so you see I have this is like my basic let's call it keys abstraction game, just to see that I can work with keys and stuff like that. Here I have another project where I just wanted to see if things compile. So this is something that I asked ChatGPT to write. So I just asked it, hey, can you write me something simple that uses OpenGL? Here I am including this. I am including OpenGL and SDL headers directly, but we are very quickly going to abstract them so that we don't do that. So this draws this thing, right? Amazing triangle. And let's go over and see what exactly ChatGPT wrote here, and we're going to abstract it into hopefully more and more usable code. For some of the stuff, we're actually going to ask ChatGPT, which is going to be fun. So, so there's a bunch of like creating Windows stuff, and we're actually going to get rid of those pretty quickly. SDL GL create context. New site build. Okay, good. So some of these stuff I am actually going to move into where is the while loop? Because there's a bunch of setup code. Oh, here you go. While loop. Perfect. Good. So if you can see, let's go back to my abstraction layer, because now we're going to think in terms of the abstraction layer. Now, the abstraction layer, when I set it up, I basically two things. First of all, I created this thing called an app holder, which currently is just like a global thing that gets created. See it here, it's just a global pointer and gets initialized lazily whenever I get the app. This probably should be called the app state, right? So it's like a state for the app. But then internally, I am creating the app holder whenever the game is actually calling me back to start it. And then there's this thing in SDL where you register the different callbacks. So I register 4 callbacks that SDL calls you back. That's how the SDL3 API works. I think SDL2 had a similar similar calls, but this is like, now when I look at the SDL GitHub, basically all their examples are structured a little bit like that. There's also a macro, by the way, that does this, but I wanted to use the manual without the macro. So I register these callbacks. These all are callbacks in my code. So for example, init function is here, and init function is just calls create window, right? There's some error handling code here. Good. And then update function, that's something that the SDL repeatedly calls you. I probably should have a frame limiter implemented here. So we're going to go over that very shortly, because right now it just calls the update function as fast as possible. But this is actually the function where you're supposed to be drawing, at least let's call it naively. Naively, you're supposed to be drawing, or maybe in the future we would just do some app state things here, and then we would draw on another thread. But the idea is that update function is like it's like this part of the game loop where you should be updating anything. You can check what the keys are, you can check what the mouse has done, whatever. You can make decisions, and then you can render. So it's like this very fundamental part of the loop. Event function is another interesting one. I just did a half-assed implementation for now, but this is a callback that you get for any kind of event. And there are a bunch of different events that you can get from the operating system. One of them is the user tried to close the window. So that's one of the options I did. But there's a bunch of other things here. You see maximize, resize, whatever. There's events here. There are key up, key down, mouse, joystick. You see there's a bunch of OS events, gamepad, clipboard. It's another interesting one. Audio device, pen, camera device, a bunch of different events. That's a big part of what SDL2 does for you as a user. It kind of abstracts these in a cross-platform way. So I would probably add more code here. Right now, I just added a little bit of code to handle keyboard events, but that's it. So I'm gonna, in the future, I'll do more. And then there's a quit function that now just quits, just destroys the app really. So that's currently my thing. And now what I want to do is I want to look at the dummy code that ChatGPT wrote, and I'm going to slowly move the init code and the destroy code and all that into this abstraction, because I want I don't want my user to do manual OpenGL at some point. Like it's gonna be like a hybrid, like a very a monster hybrid of some point of manual calls and not, and then hopefully this would be moved into a world where the user can work and draw things without directly knowing that it is an OpenGL app. Where I'm getting constantly getting emails. By the way, as I said before, if you like what I do, check out modalix.com. We just started our Black Friday deals. There's great prices on all our products, so you should be checking it out. Okay, so let's start to reflect on this really boring code that ChatGPT made. The first, I know that ChatGPT, things that ChatGPT can't speak. ChatGPT did is that I know that this part is actually the loop, and this part is actually the destroy code. The part above, some of it actually has to do with state. There's stuff like preparing the VAO and VBO and all the different buffers. I think though that's what they are. Preparing the shader, stuff like that. All these stuff is stuff that we're going to abstract. until we find, you know, the right abstraction for this to work. So, but all the create window stuff and set GL attribute stuff, all this stuff we can definitely move to our internal abstraction. So, and all this stuff, you know, whatever SDL quit, or all this stuff is already in our current abstraction. So let's see if I can, instead of including this, good. So this gives us error in all the SDL stuff, which is exactly the things that we need to abstract here. And instead, I'm going to include what I call include SDL wrapper. Okay, so the question is, this is great. So you would have some function like draw rect with instead of OpenGL draw calls. Exactly. Like the idea is that the calls themselves, we'll bring up this question because it's a great question. Exactly. The idea is that there will be more high level methods here. And then I could completely, first of all, abstract the user from the ugliness, which is OpenGL. And where am I? Yeah, and I would be able to eventually switch to another backend, right? So ideally, OpenGL would just be used for learning, and then I'd be able to say, okay, well, let's do the same thing with Metal or Vulkan or the new SDL GPU backend or something like that. Like this is really the main concepts of this whole thing. Like I want to be abstract. I want to be able to switch backgrounds. I want to know that if I port this, you know, to Swift and write this on an iPhone, I can, you know, take all the cross-platform code, keep it as it is, but just change a few system calls internally to call directly to some iPhone API. This is really the you know, the design goals of this. And while I do this, I want to learn, you know, what is exactly that those calls need. Okay, so hopefully that made sense. And yeah, and you can see it a little bit here. So here, you know, this is again my example code. So all the stuff about keys, that keyboard input that I did, that stuff is completely abstracted. Like this API part has no SDL in it. It's just like a vector of something that I call a key event with the string of the key. Yeah, so there's a question here. Though Vulkan is widely different from how OpenGL works, so I doubt you will get much knowledge about Vulkan that way. You know, I'm not an expert in Vulkan, so I'm not sure. But from what I saw, most of these APIs, I mean, there's a little bit of the pipeline that's different, but usually it's, you know, there's some shader compatibility thing, but I would probably switch that as well. Like it's very likely that I would switch to some one of these shader compilers. SDL GPU, for example, provides that, like a compilation from one shader to another. And also, you know, I could still, like I can still have a compatibility file. Like for example, if you look at something like, let's go to GitHub. And if you look at something like I think IamGUI has a Vulkan background as well. Am I wrong? IamGUI. Or actually, you know, not even SDL itself. Like even if you look, like a lot of times, like, but even here, like which backends does it have? Okay, great. So for example, this is IamGUI, which is a popular library, and it's got a unified interface, but you still can write with the same interface, but there's a different, you know, implementation. So there is a different implementation here with different shaders for Vulkan, right? But there's all, but this, it still works with the same API as, you know, the renderer that uses Metal or the renderer that uses OpenGL 3, right? Basically, they all just kind of correlate with the same API commands, and then you know, there's a bunch of matching things to do, but you can still do that. So the shaders are different, and you have to, you know, I'm not saying it's going to be the same, but there's it's definitely possible to make it stand behind a uniform API, to my knowledge at least. I'm not saying all the functionality will be identical, but that looks like when I looked at the code, by the way, the same with the new SDL. So if we look at the new SDL GPU thing, it's the same one. Like the and if you, before that I've seen, let's look at SDL. So in SDL, if we look at source, where do they put that? Where they put different backends? Render? Here you go. So here, like, you have all the different renders, right? So when you use the SDL GPU API, and you use either Direct3D or you use Metal or something, this is actually their old renderer. I think it's not a GPU API. This is their old 2D renderer. Yeah, there's just a compatibility layer, and there's some gnarly details in how this works, but it should be working. Like at some point, you can, once the API is written, you can still do that. And of course, it's not like I would have to keep like 100% API compatibility. I can also change the API. So hopefully this would work. Right. So let's see if I can do something useful. So my first idea is I want to look at my, first of all, I need to link against SDL wrapper here instead of SDL3. At some point I'm going to remove OpenGL itself, but this is the SDL wrapper. It should still not let me, still give me errors on all the SDL calls because it's not included through this library. It's hidden in a private implementation. Good. So input stuff I don't need. Init stuff I don't need, so instead I'm going to be calling just like here, it's going to be an SDL app. And eventually there's going to be a start app. But before I start app, I need to move all the stuff here into the implementation part of the window, right? Get shader. Oh, Vertex shader. What is this shader? Oh, this is using all the this is the actual shader. So these are different. Where is, no, still compiling shaders. I don't care about this. Okay, so just this stuff. Good. All of this stuff. So everything that's here would need to be moved into the app, like the internal thing. So that is in lib, window, good. So this is the actual creation of the window, and now we're going to create an OpenGL window and let's see. Okay, so this needs to include GLAD, which is okay. I can definitely make this a requirement of the wrapper. That is not a problem because that stuff is not exposed in the API. I just need to change a little bit of the linking details so that instead of directly linking here, oh, okay, so I'm already linking here against GLAD. Is that fine? Directly on phrase. Okay, that's good. Yes, okay, so it's already linked, so that's good. So that means I should be able to here my window class, still create window. Okay, the same window is created, so I don't need this stuff. set all the attributes. All these error handling I don't really need here, at least not for now. Context, this one is interesting. Okay. I might need a way to access this context, so we'll have to see a little bit how that's going to work. If the OpenGL can be created, I'm going to ignore all this error handling for now. I might need that in the future, but it doesn't matter all that much. Initial glad loop OpenGL functions, good. So let's ignore the error handling part here. Wait, so how is that used? Maybe I don't even need, I can just probably just do this. Create the GL context. Was that context even used anywhere? Let's look again at that code. Context, just in the destroy. Oh, good. So I need to store that so I can call destroy on the destructor, which I have here. So I have so I can do this thing returns to me a GL context. Okay. Oh, it's here. And the destroy for this code would be SDLGL destroy context. So before the window, yeah, before I destroy the window, I can destroy this context. So this should give me the hopefully similar, maybe less error handling, but should be similar code. So I don't need this stuff. I should be able to get, I got rid of all the other stuff. For now, I can still include glad GL just because I'm still dependent on it. I don't need to do process input. Actually move all this stuff. Oh, swap window. Swap window I would also need to abstract somehow. So let's see if I can abstract this. So this needs to be something like void swap, and swap would do this const. But to call this, I need to abstract it through the API because this is not generally known. So I would need to do this like, you know, let's start it through the app. So something like void swap. Yeah, I need to call this. I need to call this internally. Can I do this? Yeah, I need a way to call this. I need to call this through the abstraction somehow. So maybe, yeah, let's not do it through here. Let's do it through this one of these free functions. So it should be something like void swap. Swap window, swap buffer. What is that exactly? Swap window. Now in the source file, I can go to app holder. I have this actually get app. Oh, it's actually the holder. So app holder, window, swap. No? Oh, window, arrow, swap. Okay, so this is, so I basically just forwarded this call so that the caller here can just do SDL swap window, right? Without calling this directly. All the event stuff is actually not needed. And all of this would actually be called so the update loop, I actually control the update loop myself, so I can, it's something like app cool. Let's start with this, just like a global capture, which does all of this. So this is going to be the update, but it also need to have a hook for the end function. Let's call it quit. There's some user option to do this. That means I can do here in the wrapper, I can do something like yeah, so right before quitting, I can do get app quit. Or maybe I'll call it something like on quit. Maybe that's better. On quit, and here so I need to find better RAI versions of doing this, but this would be the start. So these are all stuff in this app for now. Call everything, and then actually what I'm doing is I'm going to do SDL start app. And when this happens, this is going to start calling the update function in some crazy interval. Let's see if this works. Ooh, look at this error. Tries to call the shader. Oh, so maybe the shader cannot be called until I've initialized everything. So maybe I should also have an init function that would kind of tell me that everything is, that the thing's been created. So same, just the way I did with the quit callback. Let's call this on init. And then here, I'm going to, where's my init function? Init function. Okay, so this is where I'm initting in the SDL, creating the window, and once I finish that, I can do get app dot on init. So that'll be a good time for the user app to do app on init equals this, and only do that whenever everything is ready. And that does mean I might need some capture. I have some capture things involved here because those are referenced in a few places. So we'll see. I can probably, all these, these global variables I can just put here. Shader program, where's the shader program? Here it is. Okay, so I need some way for this to know about the shader program before it gets created because of the capture problems. Let's go back for a second. Oh, now I can't undo for whatever reason. Let's see. So the shader program, that thing is used here and here. Yeah, I can still probably just do like this. Okay. Let's try now. So it couldn't create the shader. Let's see why. Vertex shader. Let's see, when is this called? Start app. Window is called. Create window. Right? Did some of these, does one of these fail? Did I mess it up? Let's go back and look at the code that ChatGPT gave me. Init, that's called set attribute OpenGL. This let's see if those init stuff are actually getting called on time before the crash. Yep, looks good. Create contacts, that's fine. Oh, so it doesn't work. Oh, because I didn't create the window. I need to call create window before I create the contacts. That makes sense. There you go. That's what you learn by not doing error handling. Okay, so I got it. Everything worked. This looks good. So what I earned from this is that this basically main things are that the window first of all was created with the OpenGL compatibility. It's very actually possible that I would add some of this as options. Like I have a bunch of stuff here that deal with for example, window options. So I probably can do something like, OpenGL version or something. So let's call it something like OpenGL major. Let's make this here struct OpenGL version, int major, int minor. And then here I'm going to, when I create it in the window, I can take options, OpenGL version major. Minor. So all these stuff are kind of user settable. I have no idea what this profile is. Compatibility. I'm probably gonna, these are more stuff that I eventually would pass as options. We'll see, but because I'm going to create a general purpose thing, I don't need to capture every possible option for now. But at some point, I will make some of these options available via the interface without exposing SDL, because this is it is very important for me to not expose the underlying libraries as much as I can. Let's see if that works, and this should be probably committed because this is okay. This is a good start. Okay, so this draws a triangle and we can commit this just so that I have something happening. Edit initial OpenGL window creation to the wrapper library. Okay, so yeah, so we got this. And now we're going to take a look at the OpenGL code itself. So the OpenGL code itself, again, you have to remember this is all OpenGL code that ChatGPT wrote. Who knows if it's good or not? But we can probably reason about many of the things that it does, and what the part we don't know about is we're going to ask ChatGPT about. So there's a bunch of stuff here in the init code about preparing, compiling shaders. So let's see if we can slowly understand what's going on. There's also the vertices here that I guess it passes that. Here you go. So this is part of the buffer data that gets constantly passed. First step to the official Modalix game engine, rivaling Unreal Engine and Unity. Yes, exactly. You've uncovered the evil plan, which is to take over the entire gaming engine throughout this entire stream. So by the end of this stream, the gaming industry would change. Yes, I love this. I love the you know, the taking over the world plans, one shader at a time. Okay, so what I want is I want to start to move a lot of these into, you know, slowly, one by one. We're gonna have functions. Some of these are gonna be hard because there's some types here that have to be shared, like whatever this thing, GLU int. But actually, those types, most of these types are not even OpenGL types. They can just be like unsigned int. All the men want to be the game engine and all the girls want to be with it. I'm not sure I fully understand. All men want to be the game engine and all the girls want to be with it. I think I'll need a better translation on the female male relationship that this exposes. This is awesome though. Okay, so next up, so shader source, compile shader, get shader IV. What's get shader IV? Let's see if you can see what it does exactly. GL get shader IV returns a parameter from a shader object. Okay, so it is that if I pass it a shader object parameter, so GL compiles. Okay, so the idea is that this checks if the shader managed to compile. That's what it is. So, oh, and this is the exact same thing. Okay, so here's something like there's two shaders here, right? So both of these can probably be very quickly abstracted. So let's try just inline write a few abstractions on compiling the shader, right, or something. So I definitely can see a lot of comparisons here, and we can probably also just use, you know, C++ types like std string and other normal types are easier to work with than so we need something. There's something here that says compile shader. I have no idea what this function needs, but it might need to return something. So Vertex shader. So it might need to return this thing called GLU int. Now, good. Fortunately, GLU int is actually just unsigned int. So we can just do unsigned int. That will make it easier to abstract. And later I probably need my own type. There's a third shader type, fragment and vertex. The third one might be compute shader. I know that's a thing. Compute shader. I know which other one. I always see vertex and fragment used in graphics, but compute is a thing. And who knows? What else? Let's see. Let's look it up. What types of shaders are in OpenGL? So vertex, fragment, tessellation, control, and evaluation. Is that a thing? This is the. I don't know if that's an actual. If I trust that results, the AI result. Okay, geometry shader, tessellation, control, and evaluation shader, and compute shader. Right. I don't know if I can use compute shader on a Mac. I think Mac is stuck with a slightly older version of OpenGL. I think I could use compute shader if I use Metal or one of the other ones. Anyway, so for now, I want to see what's needed to do this little thing, compile shader. This is basically looks like it. Let's see exactly what it needs and see if it's the same thing. This is like there's like a validation thing that happens. So, but this needs to let's do that. Let's call it shader. What it needs is the source, so I'm going to pass it like const string source. And I would just do source.cstr. No, it's not that. It's not what it needs. What is the actual function? GL shader source. Oh, pointer to a char. So like we need to be like this. So maybe I need to you know, text equals this, and then just be the pointer to the text. I think that would work. Let's see if this is kind of correct, and then okay. Never really understood the coordinates. For example, the triangle float vertices equals -5, -5, 0. Yeah, I'm not sure myself. So we are going to ask ChatGPT in a second. What are the meanings of these coordinates? Is this -1 to 1? I'm going to guess it's -1 to 1, but I've not tested. This is randomly me, you know, vaguely trying to presume that I know what I'm doing. So yeah, so we are going to see. Those are offset coordinates translations. But I think they're relative to the screen somehow. We're going to see in a second. So what I want to do is let's see if I manage to get the syntax correct, I should now be able to do auto vertex shader vertex. Do I even need to know the vertex shader itself? Yeah, probably do. Okay. Equals compile shader source, and that's it. So hopefully I should be able to get rid of all this. And is a fragment shader enough? Like, do I have to, oh, so I need to pass it the flag. So it's either a vertex shader or a fragment shader. So I can do which type it is. Let's do something like that. Let's do because I want to abstract this in nice way. Let's do shader type. Vertex fragment, might add more in the future. Type, and then I do something like which type is this? I guess this could be just an int get shader type. Okay. And this is pretty much the same thing. So, oh wait, is there a number? Or number is always the same, I guess. Okay, so I need to see what the number is, but we'll see in a second. So this is fragment shader equals compile shader. Fragment shader source, shader type. Enum class. What's wrong with me? Class. Okay. So hey, Elon Bluestone is here. Elon asks, what are you making? So I'm here just learning some computer graphics stuff for mostly to do with games, but they could be used for a variety of things. Could be used in plugins, could be used in audio software of sorts, and will be used in my little learning games, hopefully. So it's all OpenGL graphics here. Just learning some of the things to do with that. So the question is, that's where Vulkan shines. Doesn't need to compile its shaders. Very interesting. And it says, I need an RTX 5090. Is that like a good NVIDIA card? So RTX 5090? Is that what it is? Oh yeah, so it's like Yeah, absolutely. Yes, those are awesome things. Unreal 5 is insane. Yeah, those stuff is good. I'm doing stuff that's much more lower level. I'm trying to write down the whole graphics pipeline myself, just for learning purposes. Yolanda says, I will never go with NVIDIA ever again. I'm converted to AMD. That's fun. I'm here, you know, I'm on the Apple machines, and the Apple machines actually have their own graphics card, like an Apple graphics card. It's very, very good on the ARM machines. It's very nice. Runway AI is the future. What is Runway AI? Runway AI? Art video generator. Huh, that's fun. Let's put it on screen for a second. I've never used this, so this is going to be a live. A cat flying in the sky wearing Superman suit. Let's try something like a nerdy programmer, musician trying to learn computer graphics. Let's see what this does. Oh, when you sign up now. Okay. And then just do that. Come on, let's do it again. Okay, so what did it do? Nerdy, musician, programmer, trying to learn computer graphics. That's not bad. I mean, this really looks like that's very not very far from what Midjourney and stuff is doing, but it's not bad. Can I see this in a higher quality or no? Is this gone? Oh, it creates a video. That's what happens. Okay, we're gonna see for a second what it did. Okay, but until this creates, I'm gonna go back to code. Okay, so I'm going to compile this shader. Oh, I did. Okay, so I compile this. I can remove this completely. Something's fucked up with my my IDE. I need to quit and come back because it doesn't let me. This is the beta version of Sea Lion. It's always have these weird bugs. Now it doesn't let me undo. Is that it? Like bull success. I hate this stuff. GL int. Okay. Let's see if I got the compilation part to work. It'll be the first step. Oh, I didn't return the shader here at the end. So return shader. Does the ReSharper engine have template evaluation support now? partially. Yeah, it kind of works. Not always. I can't tell if it works or not, but it kind of works for some things. Right. Yeah. So this works. So that means I got the compilation part work. So I'm going to commit this. Added initial compile shader abstraction. Okay, so this was the first step. Actually, all this validate stuff is actually also the same, so I probably can do a function that says something like validate. Same thing. It's like an unsigned. Just like probably an unsigned int. Something like a parameter. Something like parameter. So it's something I can assign. So I also need the shader. So it's shader parameter, because I saw there's a couple of other validate things happening here. So let's do this. So this would be a validate shader parameter. All right, so this already looks slightly bit more cleaner, more sane. All right, good. Next up, there is stuff about attaching a program. So it's attaching. So after we we compile the shaders, like here, there's a stage where I need to, oh, here there's another thing. So this is the same thing. This should be just validate shader program. I guess the same thing, shader program, and then link. So I can just do this and remove this part. So this should be the same thing, right? The same thing, get shader IV, or is that get program IV? Oh, get program IV. Okay, so I need to do something. So just like have this should be validate shader. And this thing should be validate program. Both are pretty much the same thing, but whatever. Just hate all this error handling code. It's so verbose. So it should be like validate program. Okay. So the idea is that so these are functions I need to create the program, right? And once it's validated, I can just delete it, right? That, I guess, makes sense. So now that it's validated, I know that I can just get rid of it. So verse data and okay. Okay, and this is where I'm actually starting to create the more dynamic, buffers from my program into the shader. Oh, okay, so by the way, let's see what the AI created for me. So let's see if this looks correct and exactly like what I'm really doing. Right, so as you can see, this is an exact replica of what happened on the stream. Right, everyone saw that I was doing exactly that. It looks exactly like me as well. I do have to say, this is kind of cool. I am enjoying these little artwork stuff. Let's try something else. Let's try. Oh, so I can also upload an image and it's going to animate it. Let's see what can I, let's see, let's go into, what am I going to take? No, let's just try something else. Let's do something like a, let's do, two musicians trying to change a light bulb and failing miserably. How do you call how do you write miserably? Miserably. Yes, this one. Okay. What? I need more tokens now, so now I need to pay? Oh, come on. All right. That sucks. Okay, boring. Back in here. So I need to do everything here to do with the program. So I think pretty soon I'm gonna need to like make like a struct, because these two work pretty much combined. I think there's always gonna be a vertex and fragment shader, right? I think they're always gonna go hand in hand in a way. Maybe I'm wrong about this, but I suspect this is the case. Yeah, because I think I can actually make this whole thing be just one function, right? And what do I need after this was created? Do I need the shader row and all this stuff? I probably don't need those. Okay, now the structure starts to reveal itself, I think. What do I need after this? Do I need the program? What? I just need the program. Use program. So I just need to have that. Awesome. So this is getting the abstraction start to reveal itself to me, hopefully. I think if I would do something like a struct shader program. And I should do something like shader program, const string fragment const string vert. And this would basically do all of these until here. It would just need to have the unsigned int ID. And very soon I can actually abstract all of this thing into something that's where only this is known for now. So this is so vert frag, the vert, the frag. Good. It's done. And once you validate it, I can delete it, I guess. Do I really need to delete? Does that make sense that I delete it after I link the program? I guess that makes sense. I don't know. Hopefully ChatGPT did not mislead me. And then okay, Luis says, hi, I'm watching videos about learn OpenGL, but in Java. How are you doing to learn it easily? I don't know if do I learn it easily? I don't know. I'm just doing things here. That's a great question. How am I learning this easily? I don't know. I mean, only you can say. What I'm doing right now is I'm kind of blindly following, examples, and I'm trying to learn the structure of the C++ code. Right? So I didn't deal with any of real graphics yet. I'm really just seeing patterns in the C++, like, okay, this happens this way. Buffers get initialized like this, and I'm trying to understand the patterns of the code. It's very likely that there's going to be a phase here where I'm going to stop and learn more. But I'm just trying to one by one saying, hey, here's an example program. Why does this do that? What's the pattern here? What are the inputs? What are the outputs? Because eventually I'm trying to make it such so that the code would be like kind of separated. So I like the idea that initialize of the program is one thing, right? Because most of the time, I do understand that there needs to be here, like there needs to be some sources for the shaders, but maybe most of the time the program can just be general purpose with a bunch of crappy initialization code and just pass these sources, and eventually we can reason about the program like this. So yeah, so currently I wonder if it's correct that I'm deleting the shader here. Where's my delete program? Okay, so yeah, because delete program I can also call in the destructor. So I have the structural shader program. And the other member function I need probably is use program. Use. And the idea is now that if I will have something on the stack, what was first? Vertex fragment. So I can create this, and then when I'm using this, I should be able to do, where's this thing? I don't need this anymore. Oh. However, yeah, this comes, so I can't really initial. This probably won't work because GL context is not initialized when this happens. So I need some I can probably do this late. I could probably do something like void init, like do all this stuff in a lazy init. So this would just be created here. This would do let's call it shader program. Shader program init, these two things. And this would just be shader program.use. And let's see if I got this to work. And if I did, I can just move it out, all the shader program stuff now, and decouple it from my program. Good, it still works. I can still see my nice little things. That is great. So yeah, so I should be able to now take everything here, shader type enum, validate shader, validate program. Everything here, almost everything here, by the way, would now be private function. So there's not going to be any mention of this through the API. So this is going to be great. Let's, I'll make a little thing here called OpenGL. And I'll make two files here. One is, let's call this program. Shader program. I'll add this to the CMake. So there is another file here called OpenGL shader program. This is going to be called SDL. I don't know if it's going to be completely true, but we'll decide if this is the correct namespace to give it in a second. Namespace GL. So this is going to be a private namespace. Why should I add this shader program.h to the CMake program? It's included right here. Sometimes the beta of CLang goes crazy. Let's load it again. Oh wait, Louis said, thanks. My goal is to do a Minecraft clone in Java. And Notch did it, but I know it's a hard way to reach. Yeah, I mean, Minecraft is just such a complicated game, but why not? Why not do a Minecraft clone? I think it's an awesome project to do. I think Minecraft, the original one, wasn't it written in Java? I have no idea. I was still watching your live to learn something new. Thanks. Sorry for my English. I'm learning too. Oh, great. Well, you and I both. You know, I'm faking my English throughout this whole stream. You know, once every 5 sentences, I'd probably say something that makes no sense. Okay. This is now back to work. Good. So the idea is that this is here, validate program. Okay, good. So this should be something like GL. Good. So this will slowly start to compile, because now all the uses of GL are actually in the CVP file, so they're internal. This would probably be here. So this now looks better. So there's now, this class just has an init function. I probably should still make this a constructor. I'm not sure. We'll see in a second. I don't love lazy initialization stuff. But I had to do it for now just because I noticed that the OpenGL engine has to be initialized. We can't just construct the object. We need to have everything initialized before. So yeah, so the idea is now if I'll be able to include this, so API now should include OpenGL shader program. Some of this stuff would eventually not be OpenGL, but it's good enough for now. And here I should be able to have just this. Oh, let's initialize this. Good. Here you go. So the idea is that now nothing in the header here has anything to do with OpenGL because it just includes IOStream. The only types here are unsigned ints. It's like a basic C++ type and string for the shaders. So this makes it really easy for me to, once again, remove references to OpenGL from the user code, right? So this would be, so the user code now still has a bunch of like the vertex array stuff here, but this is good. This is compiling. It doesn't look so good. Gotta get mad at ChatGPT for writing this not correctly resized code, but we are going to debug it once we finish that part. So this is good. Let's call this moved shader program initialization into the wrapper library. Good. So we got this. Next up, let's see what else happens here. Okay, so next up, we're starting to talk about the buffers, really. So GL gen vertex buffers. So you create the buffer. This is all stuff in the init, right? And the vertices, you set them right at the beginning. Let's see if I can understand what this does. So I think this is when you pass data into the like little binding the buffer, and then so you kind of bind the buffer, if I understand correctly, and then here on the update loop is where you're binding the. So this is where I'm passing information, I believe. Okay, let's start with something even simpler. I can probably do, all the clear color stuff, right? Dark gray. So let's read about this. GL clear color. Well, this will be like the easiest function to abstract. Red, green, blue, alpha, right? Specify the red, green, blue, alpha. Values used when the color buffers are cleared. Show values equal 0. Okay. So I think does it first set the color and then there's GL clear? Are those two related? So specify the red used by GL clear. So first you set this and then you set clear. What is the mask? Bitwise or mask indicated buffers to be cleared. 3-SR, color buffer bits, GL depth buffer bit, and GL stance. I have no idea what all these are. So I'm going to imagine, the most basic abstraction that I have would just have let's create another one of these. Let's call this draw, right? pragma once, and this is going to be something like probably have a bunch of types here. We'll see in a second, but this like I probably have types for like color and position, stuff like that. It's gonna be pretty annoying to keep doing that with you know, integers and floats directly. But let's add this to the CVP file. So draw. So the first thing is to do something like clear. I also need the color. So let's have something like struct color. We have float red. Do red probably, I don't know. Red. Float it's RGBA, right? Red, green, blue, alpha. So float green, blue, we can also give it some nice float red to use equals 0 float white to sorry, green to use, blue to use equals 0. Then we can float alpha to use equals 0. Green to use, blue to use. So there's a question. I read that it's recommended to use HPP for C++ instead of H, which is more C. What is your take on this topic? You know what? I don't know. I've seen a couple of code bases that used HPP. Most code bases that I'm aware of are using H. So I just went with whatever is the most common that I'm seeing. I have no real preference. Like if you work in a company they use HPP, I'll use HPP. I'm not married to any of those. You know, usually, you know, when I saw most of the default, like here when I do new, C+ and H by default, the other ones CU and CUH. I don't know what that means. I don't know why that's the default. Honestly, I don't know. You know, like we just saw SDL. Well, SDL is kind of in C, but let's see. Let's randomly GitHub a famous C++ library and see what they do. So if I'm gonna go to GitHub, let's look for language C++. Language C++. Let's see what they do. So let's see the most stars. Like the most stars of the C++ code base. TensorFlow. Okay, that makes sense. Let's see what they use. TensorFlow. Here's the code. C, the actual C code in here. Okay. So where's the C++ code? CC, is that C++? Probably not. Okay, all this stuff is in C. Where do they have actual C++ code? Can't even find any C++ code in here. Maybe it's only C and they just lied to me. Okay, let's see what else we got. React Native. Okay, that seems fun. Let's see what React Native did. React Native. Where's the source here? Packages? That's gonna be the actual code. Why is it so hard to find the actual code that they used? Come on, give me something where there's like a source. Oh, here's go. Godot. Okay, Godot engine. So Godot engine, main, CPNH, right? That's what I'm used to seeing. Let's see another one. Let's see another code base. For the sake of it, Bitcoin. Okay, this is gonna be fun. Bitcoin is in C++, and they have source. Kernel, CPP and H. Yeah, so it does look like most people are using C++ and H. I don't know if there's yeah, it does look like personal preference. Like I don't see any, you know, I know that I've seen people use HPP. It's fine with me. I don't mind either way. All right, so what I want to do is I want to write clear and then pass a color. Const color. And then this would do in the implementation. So Acoustics here, they say that HPP is useful when mixing C and C++ in the same project. Like, you mean like giving the caller some more information, I guess? I don't know. Because usually when you mix C and C++, your compiler is actually C++. So the compiler doesn't really care if it's this or not in terms of the header. Because if you're in C++ project, and you're including a C header, there's no problem. The compiler can include it. The other way around, the compiler is not going to be able to include it no matter what. So maybe there's some flag here that says, well, from the .c file, don't include the .cpp file or something to make sure that this, kind of warn you on the incompatibility. The question is, am I a Tokyo Spliff fan? What is Tokyo Spliff? Can you educate me? Let's look it up. Tokyo Spliff. Ooh, that looks interesting. So I looked it up and it says OpenGL Vulkan C++ game engine dev. Now that sounds awesome. Whoa. Ooh. That looks awesome. It's also C++ stuff too. So I can see that he's showing. I wonder if does he actually show development on his channel? Are they like live here or something? Yeah, look at this beauty. Look at this beauty. Yes. All right. Here you go. GL frame buffer. He's doing what I'm doing. Look at this. Look at this. GLM, you see, he's doing exactly the stuff that I'm doing. That is awesome. But he's definitely way more advanced than I am at this point. His stuff looks beautiful. Oh, that's awesome. I need to dive into this. Like he's making a serious engine. He's making like an engine that looks like Godot, with a visual editor where you can edit assets or something. That is very impressive. Is this open source, what he's doing? Like, can I look at his code? Ooh, I can look at his code. Hell 2024, is that him? Hell engine. Rewrite 1 billion ++. This code base began as a CPU raycaster to explore the viability of a voxel-based idea I had for global illumination. The voxel idea didn't work at the end. The voxel grid caused lighting artifacts, but rewriting it to use a point cloud did, and here we are. This is now the new Hell engine, the engine I'm writing to house a split-string roguelike deathmatch survival horror game. This is awesome. This is awesome. But, all right. So I see this, and my main problem is, like, you can already see it's Windows only. Like, this is just a Visual Studio project here. There's no CMake, there's no Xcode, so it's Windows only. So once you do Windows only, I am like, I mean, it's cool. I mean, obviously it's awesome, but I'm really trying to do something that's more cross-platform. Like my idea, first of all, I'm on Mac now, so definitely Mac is a big target for me. But I also like the idea that it's going to work, you know, maybe some point, you know, on a phone, maybe some point on a PlayStation. So I don't like the idea of doing Windows only dev, but this guy is obviously awesome and way more advanced than I am in every possible way of game making. So it's extremely impressive. I'm going to look at his code. Actually, I'm going to switch on my Windows machine later so I can study his code. All right, yeah. So Toonie, thank you so much for turning me on to this. I'm actually going to subscribe to him, and I'm going to follow and see what it is that he does. This sounds awesome. Yeah, so he says he's going to port it. Yeah, sure. So I'm just saying from an open source point of view, I don't love the idea that, you know, you create something and it's just can never run. Like one of the things I'm probably you know, first of all, one of the things you've seen me do here, like right from the get-go, I'm starting with a CMake project. I'm not starting with an Xcode project because I know that, you know, maybe not this first day where I'm doing this, but, you know, in the next few days, I'm going to run it on Windows. I'm going to try compiling it for the phone. Like it's going to be one of the first things I do because I feel like, especially when I open source some of it or all of it, I want people to run it, you know, on Linux and Windows and Mac. Like I don't want to kind of limit myself to just one IDE, because also, like, you know, for example, my IDE on Windows is not Visual Studio. It's C Lion. So now I can't use my IDE when I work on your project, kind of limiting when you work on a team. I don't like the idea that, you know, you limit yourself to this one thing. Like, for example, if I get somebody else to help me with the graphics, which is likely if this becomes a reality, I would want somebody who works on Linux and VS Code, right? Doesn't need to use Visual Studio. So I think it's kind of, you know, but I'm not going to judge because I think that for a personal project, it doesn't matter. I don't think you need to start thinking about cross-platform immediately. It's just like me coming from audio plugins world where people have all these different systems. I like the idea that everything is immediately cross-platform. But anyway, this is not a criticism on him. This is just like me, me thinking like overthinking about this. So whatever he was doing, probably, by the way, looks amazing. So I'm definitely going to study his code whenever I have a chance to, especially the graphic stuff, because looks like he's way more knowledgeable about 3D graphics than I am. Okay, so clear. All I wanted to do is grab code from here, just abstract this. Dark gray, whatever. So I'm just going to do something like color red, color green, color blue, color alpha. Yeah, so now instead of doing this, we can just do STL draw clear. And I can do something like 0.1, 0.1. That should be the color. So that's how I clear this. Let's see if this works. This would be my first step to abstracting the clear call into a unified call. Good. Looks pretty much the same. So I should be able to clear this, to commit this, and do something like added initial draw namespace and clear function. It's not much, but first step. Let's see what else. The other thing is I want to understand how all these, vertex arrays and the vertices. So the vertices here, this is all being passed. Yeah, and if I understand correctly, maybe I need to reread about this, but I think that, do I need to keep passing, like when I call GL array buffer, right? There's a few options, array buffer. I need to read about all these different options. Static draw, what are the other options? Static copy, static read. I need to read about all these different options. Oop, almost dropped the stream just by clicking something. Okay, so the VAO, so GL generate vertex array. Let's see if I understand what each of these things are doing. So let's read that documentation. So GL vertex arrays generate vertex array object names. So this is an array which generate vertex array object names are stored. Okay. Returns n vertex array objects, names in arrays. We guarantee the names form a contiguous set of integers. However, it's guaranteed that none of the returned names was in use immediately before the call. Okay, so it means that it gives me so like this is almost like calling new, and I think this is the index. So I think those are indexes that I need to keep track of. How is this VAO used? So, okay, so it's being bind. Now I think this is like an actual index, right? So if I use when I do this, or is this the size? Is this just how many objects? Like if I create more of these, let's ask GPT about this. So let's see. So let's go back to my GPT chat. All right. Know more about some of the calls you've used. For example, what does the 1 mean? Is this a number I should be keeping track of? Is this the size of the array? Okay, so and number of VAOs you want to create. For example, you're pressing 1, which means you want to create 1 VAO. Okay. And the other is a pointer to an array, which it will generate the array identifier. Okay, so this just creates it. It doesn't even, this is just like the index, I think, of the thing, right? So for example, if I'm going to start to abstract this a little bit, I think this needs to be, it's going to be called something like a vertex array. And I think this is like the ID. Basically, it's going to be an unsigned int ID. And I think this just fills it. So I need to so if I create it, if I do something like like int size, right? This I should be able to get away with this. Size ID. and then I can just bind it. So I should be able to do something like void bind. And then next one up is to delete it, right? Just delete vertex arrays. Oh, I might need to keep track of the size, right? It's like, like a vector, basically. So size to use, size use. So I think this is generally, they're probably going to be helper functions for me to set or get things from this thing, but this is, I think, the idea. So the idea is that if I have, yeah, I'm keeping having the same problem of initialization because I can't just do this. I love the idea that I keep having this init things. I would much rather, yeah, I would much rather do something else. What I would much rather, I think I want to change my abstraction layer a little bit. I think what I would want is, yeah, I think what I would want is to be, when I'm called with this, I think ideally I would, instead of passing a function, I think what I would want to do is get a class created. I think that would be much better. I think I need to, I can improve this for sure. Yeah, so yeah, because I mean, instead of doing all these functions, one way is to do it through inheritance. I don't usually love inheritance, but in this case, it might work well to do a couple of inherited properties or something, so that I can do, yeah, this might work well. Basically just make a yeah, basically make an interface, just an interface with some yeah, maybe a little less composable, but maybe to be more ergonomic, because then I would get a call to create the whole object, and then everything I do just in the construction, everything's just going to work. I think this is just going to be much more ergonomic. Yeah, I think that's going to work. So what I'm going to do, instead of creating the app, like this, so this is more something like the app. Let's do this. So this is something going to be almost like an app manager or something like that. App manager. It's not really the app. And the app is going to be something with like an interface to this. Instead of all these callback functions, it's going to be something like would have something like an app. It's going to have like a virtual destructor, and it's going to do something like virtual void update. And then I'm not going to need all the onQuit and onInit stuff, because that's all going to be just constructor and destructor. I just need an update, and maybe I need the key function. Yeah. Let me think about this. Yeah, so this is not even going to need that. what this does, this is going to need is, am I including my own data structures here? Good. So I can use my own data structures here. So it's going to be like a owning pointer. It's kind of like unique pointer, but with slightly nicer things that I've added. So it's going to be an app. And then this is going to be fun. There's only going to be one function here, which is going to, and it will actually probably be this is going to be something like a callback function. Let's call this create function. Yes, I like this. And I'm probably going to add a template in a second to make this really nice. So it's going to be just one function. It's going to be fun. Okay, so now this is my world. Abstracting these things in a ergonomic way, hopefully. So here I'm going to create an app. So this can just do app reset. Actually, this doesn't even need. Yeah. Do I need to delete it? Delete the app? I guess I can. I can manually delete that. And then update function to get app.app update. Good. Creating the window is going to be create function. That's good. And then let's start with this for a second. Let's go to my basic game now. That doesn't do all that much, but it's a little simpler than this thing. Good. So instead of doing that, I'm going to do something like struct app inherits from STL app. And it's going to I'm actually going to make sure that it has struct app manager. This isn't the app manager. Let's call this app state. It's much better. App state. PR. And here I can just do something like create. Func, and then app state equals this. So there's going to be access to this. And while I'm here, let's do void destroy to less expose these private members. So just like app reset. Good. Let's move these to the CPP file. Oh, there's no CPP file. Okay, there's going to be a CPP file pretty soon. So yeah, so this now I should always be able to like state state pointer key handle blah, blah, blah. And then so I don't need to do app.update. I just need to do app.createFunc equals no, it's not a callback function. It is it needs to be something like a std function app. App like this and create function. I'm going to change this in a second to be more ergonomic than this even. So this is just going to be return new app. So yeah, so this is basically going to be the main function. Everything else is going to be here. And now I'm actually going to change this to be a template in just a second. So app equals this. Yeah, and maybe I don't even need this. I can literally just do this as a. Don't think I kind of wanted to do this as. Let's call it appset base. And this would be struct app state and hit that template, type in T. And let's make a virtual destructor here. I don't really know if I'm going to need. Yeah, so I don't need this. Probably don't need a thing. I can just do virtual app, create app, 0. Turn UT. Can I make this const? Probably could, right? Yeah, so that's for now all it's going to do. Create app. Can I not do this now? Why can't I do this app state? App state base. Sorry. Okay. Yeah. So this should allow me in my simple game to do app state app. Just do this. And I don't even probably need to call start app. I can now just remove all of this and just do. Where is that thing? Yeah, let's have an SCP file here. Good, and I just need to probably I can just make this a private function or something. Yeah. What is this start app thing? Clean up the implementation of this a little, but base. Great. Really what I want to do is I want to when I create this I should be called start app, right? So I should be able to include wrapper and call start app with this. Is this true when I'm here and I'm calling No, this is no, this is not true. Because when I still need a manual start app. Otherwise, oh, I just probably need to template start app. That's what I need to do. Right? Like when I'm calling, yeah, I can just make it start app. This is what I need, not this, not to template this thing. This is just what it should be. And then let's look at the API again. So this is just going to do how am I going to do this with calling so it would need to be something like start app internal or something. Let's call it namespace because I do need this be kind of exist from here, but this would be like internal. This would be here. Internal. Do I really need to make the app right away? Probably not. Yeah, I don't need this. I don't need this at all. This can just be, let's call this thing app state again. This does not need the inheritance stuff. Here, I can just make this have what I just did before. So instead of this should have the stud function that returns an app. Called create app. And then when I start this, yeah, I think so. Now I can do this. Now I should be able to do this thing. Void start app takes nothing. Right? Because the thing is I need a way for this to be held. Yeah, but why can't I could just make this whole one giant thing a template, right? How am I going to do this? Because the thing is, I need to create this somewhere. Which it could be a singleton. Like I don't mind it being a singleton for the purpose of this app. I don't need to run multiple apps. I don't think it's ever going to work. But yeah, so I should be able to do static t app and then start app. Sorry, and then internal. I think this should work. I hope I'm right, but I think this should work. And this, no, I don't even need to do this. I can actually do app state static app state app, and then app dot create app equals return new t. It's kind of assume default constructor, but I don't think this is going to be a problem. Yeah, I think this is the idea. So then I should be able, from my game, to just do start app. I think this is the more the more ergonomic way to do this. Let's see, did I get this correct? I might have missed something. So let's see if the basic game works. It works. It does all the keyboard handling, blah, blah, blah. Now let's see if I can do the same thing with the graphics test. So the graphics test, instead of creating app state and the shader, we don't need this anymore. Instead, we can do something like struct app inherits from STL app. And there is an update function here, but now this should simplify all of my data structures, because now on init stuff, everything is just going to go to the constructor, right? So I should be able to and I can also now get this back into the constructor, completely remove the init function. I hated the init function. Oh, sorry, this is the destructor. There's going to be a destructor here, taking these things. No need for an init function. The contents is going to be init, so it's just the same thing. Okay, that's good. And then that means that my app can just have a member of the shader program called Vertex source fragment source. I don't need this object at all. Everything that's here called init, blah, 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 blah. This stuff is actually just constructor, plain old constructor. So app, right? Some of this stuff can just be statics, but we'll see in a second. These might need to be member variables for now, just because I didn't finish doing them. On init, okay, so all init is basically constructor. No need for this because we're doing this already. Update is this. We can remove all of this. On quit is literally just destructor. Look at this beautiful RII mechanism. App override the virtual destructor. All of those are going to be wrapped pretty soon with other objects. This is going to be so much better. And then main is the same thing. It's just a start app with app return 0. This is all my main function. Let's see if this works. Oh man, this is a much better, much more ergonomic style, right? There's an app. It's going to hold things. Very soon, these objects are going to get simplified, right? Because we're going to do these abstract things that do not expose all the OpenGL things, and hopefully we'll start to have an ergonomic thing. So there's only 3 functions here. There's the constructor, destructor, and an update function, and just the scope thing. Just so the destructor just happens when we. Oh, let's see if that happens correctly. So I close the app. This gets called. Good, because when I close the app, this is fun because when I close, even though it's interesting, even though this thing is static, you see this actually gets called to destroy manually when the app gets destroyed. So this gets destroyed in a scoped way. We can now make an object, by the way, that does this. Like it's also going to be like instead of doing start app, we can do an object that's destroyed at the end of the scope. That may be this also a nice way to do this. But anyway, I think a function is nice. Start app, it creates the object. It's called to create the app when needed, like when everything is initialized with OpenGL and blah blah blah. And then so let's say refactored init destroy lifecycle with inheritance to add clear lifetime and update cycle. Good. Okay, so now let's, so I started to work on this vertex array. The idea was that the vertex array is basically VAO, so I can put this vertex array so basically VAO instead of a raw int, and that means that this should just be VAO. Let's call this VAO like this, VAO bind. This would be VAO. I don't even need to do this. This is happens in the structure. This is obviously there's another bind, so there's always a bind. That's what they did. Yeah, so I guess there needs to be like an initial bind. I'm not sure why. I'm not sure why this should happen, because this happens anyway. I think this might be a mistake on ChatGPT part. I'm gonna see if this works or not. Yeah, I'm not sure this. So VAO, I think this gets generated now anyway when I created this. Yeah, I'd be interested in seeing, because because I'm calling this in the constructor now, generate. Right, I don't think I need to do this anymore. Maybe the program has to be created before. I need to check that. But this is not needed. I'm not sure this is needed. Okay, so this needs to take a size, and I think let's make the size be 1 by default. Oh, VBO. Okay, so VBO. Make it initialized. Good. Okay. Let's see if this works. I love how fast everything compiles. So quickly, loads up right away. And this doesn't work, probably because I'm still missing the initial that early bind that I thought I could live without, but maybe I can. Like if I add this bind, VAO.bind. Why do I need this? Yeah, this works. Why do I need this initial bind? That's interesting. Okay, so maybe there's something in the in this initial, because this always happens, right? Yeah. So I wonder. But this is let's put it in just because I don't understand OpenGL just yet, and I just want to finish abstracting this VBO one, which is an array buffer. So this was a vertex array. The other one, right? Vertex array. The other one is an struct. What did they call it? Array buffer. Buffer for array buffer. So that needs this thing, which I can make an unsigned int ID. So same thing. I'm going to initialize this with a int size to use equals 1. Okay, generate the ID like this. Because I wonder if maybe I should just call bind on construction, if that's what it is. Yeah, let's try this. I think maybe that's more correct. Because it doesn't look like it gets set or anything. Maybe I should just do immediately just do bind after construction. And same here. So the bind call looks like this. Okay, but this is interesting. GL array buffer size. Okay, so I think this is where I set the data, right? So this is beyond just a yeah. Okay. I'm trying to send more about the state machine of OpenGL, but there still needs to be a void bind here. So I should be able to get rid of this. Okay. So I think this is actually setting of the data, but I wonder if does this just work because this follows this? So there's like a state machine of like this remembers that the last bound one was that one. So let's read more about GL bind buffer. Target to which the buffer is bound, which must be one of the buffer bindings target. But what does it mean to bind the buffer? Okay. GL bind buffer binds a buffer object to the specified buffer binding point. Calling GL bind buffer with target set to one of the accepted symbol constant and buffer set. If no buffer object that can exist when it's created, okay. When the buffer object is bound to target, previous binding for that target is automatically broken. Buffer object names are unsigned integers. The value 0 is reserved. There is no default buffer object. Okay, set. Buffer set to 0 effectively unbinds any buffer object. Okay. Buffer object immediately after it first bound is an unmapped 0 size memory buffer. Okay. So I think that is once you bind it, then the next calls the same type. So maybe I should also store the type, but we'll see this in a second. So I think once you do that, then if you get like I think when I like for example set the vertices into the VBO, then it knows that I'm talking about this last one of this type. I think this is how it works, like very like a serial state machine type. I'm not 100% sure that what I'm saying is correct, so I'm going to look more into this in a second. So I'm just going to call bind by default. Yeah, because it didn't look like before it was setting anything in that one, so we'll know more in a second. But it doesn't seem like there needed to be an initial bind here. I don't know if that's true or not. Okay. Anyway, but there's also a destructor here that does GL delete buffers. That means I don't need the explicit app destructor anymore. I can just do that. This ID. So this is size. Did I use size in the destructor in the other one? Yes. Okay. Let's make sure I don't have any one hard coded there. So I think I should be able now to do, this is called array buffer VBO. Remove this. So I don't need this. I don't need this, but I do need something that sets attribute pointer. Not 100% sure. What are these other ones? I'm not sure about these other ones. So there's going to be some reading for me about this. Let's see. We'll see in a second if GPT can do that. And I probably can. Okay, so draw arrays, triangles. Interesting. Okay. And now when I'm setting vertex attribute pointer, so this would be an attribute in this somewhere, right? Like with the position, maybe the position. In vec3 a pause, right? So this might be the a pause thing that's here. I'm not 100% sure, but I'm pretty sure that this is something like void set, and I think this needs to be something like and size. Like size data, and this should probably call bind as well. And then, but instead of doing the size off thing, I should also, if I would make this like a nice, instead of being like a raw, wait, size off vertices, right? So is that true? Size of vertices shouldn't be. I mean, I should be able to do now Vibio set. This isn't perfect. Let's do oh, sorry. This one is actually an array buffer. All of them probably need a similar method. Oh, and how do I know it's always static draw? I probably don't always know that, but I'm going to make this the default for now. For I'll understand exactly what I'm doing. Okay, so this still works. I still have no idea when. Oh, and look at this. This now works as it should. There's great resizing. So whatever bugs that were there previously, I fixed them. Whatever bugs that ChatGPT was putting in there. This looks good. This always gets update. Oh, it's not. So only during the resize looks correct. Whenever I let go, it looks bad. Okay, bug is still there. Okay, but this is. I'm going to insist that this is a ChatGPT bug. Good. So now that we've done this, we can take these two types. They're not perfect, but there'd be a good start because I just wonder what gets set here. Just to be clear, is the size of going to be? It's going to be the actual size of the array here. Yeah. So it's the size of the. How many things are in this? 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's yeah. So 9 times. Does this make sense? 9 times 4, yeah. Okay. Yeah, 27, 36. Yeah, it's fine. Okay, so I think what I need to do, instead of doing this as size off, I can just do something a little better by using, instead of float vertices, let's do something like a vertices equals to array float. What do I need to put the size? Or maybe I can just do std array. No? Let's do get vertices. Return. Can I do that without putting in the type implicitly? Okay, 9. Yeah, so it's gonna be reduced, right? Let's just do that. Std array float 9. Or I can just do a std vector, honestly. So just like a std vector float. And then instead of putting this here directly, keep this other comment bottom right. Set t data, and this would hello, how are you? This would set a data.size times size of t. Can I do that? Let's just be a const, so I can just do a set get vertices. Now what is I missing here? Set well, the versus is not an array. It could be an array. But I wanted to generalize it for a vector because I'm probably going to be using vectors most of the time. And if static arrays are not going to be that useful here. What I'm thinking of the things that I'm going to be doing, so I want to generalize this for vectors. Anyway, what did I do wrong here? What did I get? The error is blah blah blah. Oh, this would be a const void. It's a const vector. All right, good. So that helped me a little bit. I can do something to the data. I probably need something else for the type there because there's a few types of data, but this works. Here's my little triangle. This is probably good enough for me to start moving these into like the implementation. So let's remove these two types. Go to my library where it's called shader program. Let's just put them here for now. because now I can move all of these into a CPP file to take care of all the lifetime stuff and all the GL calls internally. Good. So now we have cleaner types that for this array buffer for this vertex array. Question is, can C++20 now optimize vectors now anyway? Maybe. I'm not even thinking about this right now. I'm thinking really about like understanding the OpenGL stuff, and I know that I'm going to have vectors being passed here, so I think that it just makes more sense than static arrays. I don't think any kind of optimization would matter much because probably most of these would be pre-constructed. So, and the actual copy pretty much the same thing. So if the call itself can be optimized or not, I don't know if it matters. Like eventually this probably does just a mem copy of the chunk of data. That's why also I had this interface, which may also come in handy. Bind, move it again. Yeah. Anyway, so the idea is that I made this array buffer vertex array, and from the perspective of the user program, these would be STL. Okay, so now I could make all these calls, which are much cleaner. There's very little, as you can see, very little direct OpenGL calls left. Very soon I could probably remove the include to GL here and just abstract this, and then I would understand more what I did so I can actually do more useful things. But this looks good. Like I create the VBO and the VAO, which are I'm not sure exactly what the VAO is used for. The VBO is definitely the actual positions, because the VAO I didn't put any, at least the original, I didn't put any data in it, which is interesting. I need to see exactly what they were doing in the original implementation. It's funny when I do something like I half know what I'm doing. I don't really know what I'm doing. Last thing I wanted to add here, I wanted to move draw arrays. Just like I have clear here. I wanted to also do draw triangles. Let's do that. All right, so it's draw arrays, and then it says that it's triangles. Kind of weird. Let's see what draw arrays does in terms of the connection. So draw arrays, sequential elements from line strip. So it does need to know which ones have been there before. Use count sequential elements from each enabled array to construct a sequence of geometric primitives. Yeah, so that is that if I pass it a bunch of buffers. Okay. I always wanted to try 3D stuff from 2D functions just for fun, like handling projection and transformations completely from scratch, but I never dared to. Well, we'll be doing that here. Hopefully it's going to be useful. I'm going to, once I figure out exactly what I'm doing and everything, I might use, there's a good math library, pretty low level, called GLM that helps with the transformation. So I'll attempt a bit of that. My initial goal is to see if I can do very basic shape animation, just move shapes around, maybe make them bigger, smaller, really basic things. But using some projections and stuff like that would be fun. Yeah, so pixel by pixel. I mean, you don't really do pixel by pixel with these APIs. I think you can. I can kind of draw pixels if I want to, but it's not going to be very fast. Like ideally, you want to pass a transformation matrix of sorts. I think it's just going to be faster, but you still do the math yourself. But it's just like you do the math on lines and triangles. And I'm not an expert in this stuff. Anyway, what else? Before I take a little break. Let's see. What is 0 and 3? What are these arguments? First and count. So it's like how many arrays here? Like that's what it is. So I need to how did it know to do these 3? Or is because I passed 3, 1, 2, 3. Is that what it is? These are the 3. I'm really confused. Let's see what happens. What if I do 2 here? What's gonna happen? Oh wait, no, I forgot that I have an unimplemented function here. Okay, no, just get nothing. So I think the 3 here, I think it assumes that the things that I passed are 3 triangles because of this. Because of this, I think this is the idea. Might be wrong. So there's something here. The only way to draw a pixel in OpenGL is a square, 2 triangles. Okay, that's what Exoacoustic says. Or send an image from the GPU, from the CPU to the GPU as a texture. Yes, this is how I've always been explained the terms. Is that you don't, like, the GPU itself doesn't know about a pixel, but you can fake a pixel. Yeah, so that exactly is my understanding, that you have to use like the system they're doing here with the textures or like primitives that exist inside of the system. So there's a great comment here. I don't understand nothing, but I'll watch it so I can sleep. Well, I'm very happy to hear that it's helping sleep. I wish it would help me sleep. Yeah, this is a great comment. Thank you for watching. This is from Sonhadora. I hope I'm saying this correctly. Sonhadora. Okay, so the comment is, oh wait, first of all, I meant, like, for instance, draw a rectangle with juice stuff and fake 3s by moving points and skewing it. Yeah, you can definitely do that. I think these are the kind of things that you many times do when you calculate, a projection matrix. I think this is exactly my understanding of how this works. Again, I'm not an expert, but I think this, like, because you can work with the matrices, you can look at the matrices point by point if you want to, like, kind of go over them within this kind of scale. This can't just draw a pixel has been source of frustration for game developers since the 90s. Yes, that makes a lot of sense. It's very interesting, the way these GPUs work. is that they really are at their best when you're doing, these broader strokes, matrices, or transformations or something, just because then you can pass on the calculation instead of manually sending just a big array of data. I think it makes sense. So I'm going to, if I want to, I can draw as many pixels as I want to. I have so many unused pens at home. You can always draw on the screen. So much fun, just paint on the screen. Anyway, hopefully I'm still coherent. The main thing I wanted to do is I wanted to go to my draw API. I want to add a clear function here, just like draw array of triangles. I don't know if this will be the best interface for this, but just to that I can abstract this include triangles, and this would be something like int start, int length. Start length. So this would be stl draw array of triangles 0, 3. I need to think better how to do these commands, but this is just like my first thing I can think of, because so I want to and then there's the vertex attribute pointer. Okay, so the color here is hard-coded in the shader, but the position, is this actually the position? Is this first attribute the position? GL vertex attribute pointer attribute array. Because I think is 0 the index. Let's see. So when I do vertex attribute pointer, but you know what? Maybe I should commit this first. Just make sure that everything compiles here. Just commit this thing that I did, because I'm not 100% sure all these abstractions are 100% correct. I think they're correct from a C++ point of view, but I'm not sure they're 100% correct from an OpenGL point of view. Okay, so let me commit this and say refactored. Vertex array and vertex, what was the other one? And array buffer into the library. Okay, so this is this commit. And so vertex attribute pointer finds an array of generic vertex attribute data. Okay, and this is the index. Yeah, so I think this is what I think. So this is just like an index for this attribute. Yes, this makes sense. And then enable vertex attribute array. So to enable and disable generic attributes array. Okay, so this is, that makes a lot of sense. But this is interesting. This binds the array buffer, because this is not an array buffer. The buffer is this other one. Maybe this should have been connected to, right? Because when I use the buffer array, so the one is buffer data. Yeah, because why do I need to bind these again? I'm confused about this. Are these all actually connected to this one? Because Or is this 0 as in like null PTR? So buffer. Okay, so the idea is that I think this is just like an init thing, if I understand correctly. Do I need this? Why do I need this? Enable vertex attribute array. Why do I need this thing? Like, if I don't have this, is this still gonna work? Yeah, this still works just the same way without it. So I'm not 100% sure why this is needed. Right? Because I guess it's just like because I think, if I understand correctly, when I work with the other one, it's gonna be the same thing. Like, why do I need to return my leaking memory if I don't do this? I don't think I need this. Enable vertex attribute array. I think this and this are connected, right? These are like the same indexes. So when I do this, array of generic attribute data. Because how did this know? Float false 3 false. I'm trying to understand how, if this if the idea was that this somehow, like, what happens if I don't do this? I'm guessing this is what bound the attributes. Yeah, so this makes it gone. So I think this is what connected, if I understand correctly, the vertex the vertex array, right? Which one did I say? VBO. So this one kind of connected the VBO, I think, into this, right? Like, that's how this was set. Like, it told either the source is this one, and I'm guessing the 0. Index attribute to be modified. Because this is 0 because it's that 0, and then when it says enable vertex attribute array. Okay, then index enabled. Let's see what ChatGPT can make sense with what I'm doing. So let's see. So I've started to create abstractions around your initial code, and this is what I got. One, I wrapped vertex array and array buffer and classes. Then when I use it, see if it can understand that much code. Can you now, this works. Can you now explain this line and this 2 lines? These calls work together to specify the layout of the vertex data in your buffer and enable the specific attribute location. Okay. Yes, that's what I thought. So this is a position. So it kind of tells it, hey, well, the first one is an array of 3 things. Number of component, okay, GL float. It's a type, great. False means that data should be normalized. For GL float, you just pass GL false because you don't want a floating point. If this was integer data, set into GL true would map the values. Interesting, so I don't want it normalized? That's interesting. Okay, this is the size of 3 times the size of float. That makes sense. Enables the vertex attribute as a specific index. We call this, you allow object access to this attribute when rendering. So this connects the OpenGL, the first state into the VBO. Can we also connect the VBO by a string and not an index? Here, I like this. So get attribute location. Here, I like that. Okay, this looks pretty good. So that means that I should be able to make a more, a more dynamic way of connecting this, I think. So that means that I should be able to do something like even, for example, within the vertex array itself. Vertex array was my VBO array buffer. So I should be able to do something like link to constant string see something like name. Oh, and I also need the program, so I need to, maybe I'll put the program right on top here. So program, maybe it can be a const program. And the size here is actually interesting. Because maybe I can just make this whole thing be aware of the size somehow instead of... because this is like how many. Because if I said this already, I should know the number of items, right? I can just select num items. 0. Three times, so yeah, so this is exactly the size. So I should be able to, let's call this data size. Data size. What's this 3? So I also need to know how many items. So I do need some way to store the actual data in here. Maybe I probably need to template this so that I can know what the data is. But yeah, because I think what might be useful to also do in num items equals 0 or something. Items. Yeah, I probably need to have like some way to store all these things. Name.str. Okay, and then let's see if I can go over here. And do qbo.linked to shader program a pause. So this should make it more readable, right? The idea is that, let's see if I did this correctly, right? Because it's all GPT. No, of course I made it wrong. And I set the vertices. Did I set everything by the time I got here? No, I know it's 9. Oh, because it's not 9. No. So I need to. So this is not what I thought this is. This should be. Yeah, I need to let it know, because these are basically structs almost. I think I need to let it know. Right, what is this? So 3 times size of, yeah, so I need the size of each, because these are almost like structs. I need to let it know that there's 3 structs happening here. Interesting. I'm not so sure how to abstract this correctly. I need to somehow pass. I need to somehow make it known to that link thing that program ID neither. Okay. Yeah, because to make it complicated, these are basically three arrays. So they did 3 arrays, and each one is 3. There's probably a way to do this with a struct or something, or yeah, I'm gonna start with putting this in like hard coding this, or putting this as a let's do something like int num items int size and item size. I'll just do this just because I can't think of a better solution, but it's not a good solution. So I should be able to do this, and then 3 times size of float, right? Okay, so this draws this, and that means I can now actually remove the include to OpenGL here, right? It's not the perfect abstraction, but Yeah, but in this case, I think this is okay. Like I got this to work. So it's not perfect, but it's a start. Like there's nothing here. This app only uses these little these calls. They're not the cleanest calls. I'm not happy with this level of abstraction. It's a little messy, but you call shader program, you bind VAO. Not sure why I have to bind it every time. I need to know more about the order of calls here. I need to know more about the thing about linking, but I still think this is better. Like let's make this the wrong one. I want to see if this fails. It's also print an error, by the way. Good. Attribute apause is not found in shader program. Okay, that's good. That's a good error message. Because I want to make sure that if this exists, this would kind of connect to this apause, right? This is the idea. Good. So this is a good start. Let me commit this. Added a way to link the variable name from the array buffer into the program. Good. That is pretty good. All right, I'm going to take a few minutes break. Hopefully people are still here. I've literally been broadcasting. Okay, so I want to say hi to, what's the name here? Manchas Dev, right? Am I saying this correctly? Manchas Dev, yeah. How are you? Good to see you. I've been broadcasting for, I realized I didn't get up from this chair in 3.5 hours. I really got on a roll here. This is so much fun. I want to continue. Might need a few minutes break, but yeah. So what I was doing, let's sum it up what I did until this point, just before I can take a little break. What I was doing is I'm working on creating these little OpenGL abstractions. So what we were doing before is I have this, there's a little abstraction library that has things to do with creating the window, handling a little bit of events. It's very simplified, really. It doesn't do that much. And what I did was I took some code that ChatGPT wrote to do with OpenGL, and I refactored it so that from the app side, let's look at our app side here. The app side does not include any OpenGL calls. It just has these objects like shader program that you pass the sources, and Vertex array buffer, and hopefully basic calls around these. So that means that the user of this, which is still simplified, like there's a lot missing with users, does not need to include OpenGL. The user has a few higher level functions. I'm still not sure I even understand everything that I did here. I need to read more about the order of OpenGL calls to do this correctly, but my goal is to continue this a little bit so that we can create, animated shapes and other objects of interest to make this work. Because I think this isn't so bad. I mean, I don't like the idea of the shaders directly here. We'll think of maybe a way to also write the shader in user code in a more expressive way. I don't want to hard code the color. We need to kind of switch to changing this, but hopefully ChatGPT will help us along the way so that we can slowly shift into something more reasonable. The comment is, I am from Uruguay, so my English is some bad, but I understand you. Are you really new on OpenGL? Yes, I am new in OpenGL. I read a little bit about it, but so I worked with things that wrap OpenGL before. I worked a little bit with OpenGL, doing similar things to this, but never getting serious with it. So I felt like it's time to crack the code, learn the process of how this works, of how the state machine works. I still, I've only been doing this for 3.5 hours, so there's a little bit more for me to become an expert, I think. But the idea of this flow is that, I can kind of observe the flow of this whole app from this one thing with much less of the raw OpenGL stuff. Hopefully we can over time see what is needed for, for a better program. Like, for example, if we're going to do some animation of sorts, that could be good. All right, I'm going to take a break, a few minutes break. Feel free to keep the chat going. I'll just take a few minutes break and be back shortly. All right. So while I was gone, a couple of comments here. So the comments are from Manchas Dev. You talk very fast. Can you speak a little slow so I can understand better? I speak fast. That's a problem for me, but it's always been a problem. So it's going to be difficult to change that. Because my native English is Spanish, but I study English in academy since 2 years old. But I understand a little when an English person talks. Yeah. The problem is I'm not an English speaker. This is my second language, so I'm trying to be understandable. Doesn't always work. It's my accent is also kind of weird, so I'm trying to make sense, but I can't make any promises. It's my control over the English language is limited. I really envy when I see people, lecturers who are just, native English speakers or just can speak so well. I'm not that person. Even though I've been speaking English for years. Oh, I'm getting a little better. I don't know. It's the limitations of where I was born and where I spent most of my life, which is not where they speak English. I don't know how it is in South America or Central America and all these places, because I know the language in those countries is not English, but maybe because you're closer to English-speaking countries, you hear it more. I have no idea. I do know that there's some countries that I went to, like the Netherlands, where everybody speak amazing English. I don't know why that is, but they're so good. Because it's not their native tongue as well, but they're just natural at it. I don't know why. Maybe someone from those places can explain that to me. All right, I wonder if I can continue. I'm getting a little bit dizzy from coding that much. Might be good to go on a break. Maybe it would be right. Well, I'm hoping that wherever you are, you've enjoyed this. I'm going to try to daily do a little broadcast here. See if I can find the time, because I really want to continue. I really want to have more control over this. So what I'll probably do literally as I get off this, I'm going to listen to some tutorial or see if I can, kind of observe or grasp more information. There's something about the state machine of OpenGL. Like I think the logic of it makes sense to me, but there's all these like details where I'm not clear about, like how do all these variables connect? What is the correct way to pass variables? Because it seems to me like the idea is to compile the program once and then pass these buffers constantly while the program is running. For example, pass, if I want to make an animated thing, I think I should be able to pass a different position of the triangle. And then I should have like some math function that kind of calculates this and keeps updating the one buffer. And then maybe what I can do is I can wrap this with some normal C++ types that kind of behave normally, but I'm not sure what the right abstraction would be. All right. So hopefully this was useful to you. I'm here, learning how to do computer graphics with the hope that this could be turned into a simple game very soon. Like hopefully after a bit of battling this kind of syntax, I can start. Probably I'll start by making a little puzzle game. I'm thinking that I'll do something. There's this great game that I love called Threes. I might make like a little clone of that game. It's a fun game that it does have the element of a little bit of animation, where you kind of drag the little boxes on top of each other, the number of boxes, and you kind of keep solving this infinite puzzle. I would love to do something like that, and I think I understand the basic concepts of it, but I should be able to code them in once I know how to put in the graphics. All right, so have fun, have a good night. As you can see, hopefully, maybe it's obvious or not, but I look pretty tired. I will be back. Please, subscribe to my YouTube, to my Twitch if you're watching this on Twitch, Twitter, LinkedIn, Facebook, and talk soon.